All right, so using function notation to represent an evaluated function, we're going to be looking at that. We're going to look a little bit at piecewise functions. Sometimes people struggle with that kind of thing. Domain and range, as well as graphing by using transformations, all the shifts. We're going to talk about the shifts. Using the vertical line test to determine whether y is a function of x is another thing we'll look at. So starting off here, it says if f of x equals x squared plus x, evaluate this. So I'm sure you all got this one right because it's just like our warm-up problem. We have to substitute in for f of x. Here it is, x squared plus x minus. Now I have to evaluate f of 2. 2 squared is 4, plus 2 is 6. So I have minus 6 all over x minus 2. Now I cannot cancel terms. Here's a mistake I see people make. They cancel out the x, they cancel out the 6 and the 2. Those are terms. You cannot do that. The only time you can cancel is if you have it completely factored first, then you can do your canceling. So it should be x plus 3. Domain and range. So the domain are the x values which can be used for a function. And it's going to be all real numbers. All real numbers can be written as negative infinity to infinity. Unless the function is rational, has an even radical, or a trig function. Every domain is all real numbers unless we have one of these situations. The first one, rational. A rational function would be like y equals 1 over x. Rational just means that we have a fraction. Rational, fractional. What is it in a fraction that we cannot have the denominator equal to? 0. So if I'm doing a problem like this, I have to say the denominator cannot equal 0. If I have an even radical, such as y equals the square root of x, y equals the fourth root of x, then I also have to look at this. See, this is really an even radical because there's a 2 there. We just don't think of it. I can't take the square root of negative numbers. I can take the square root of 0, though. So what would I say then? Under the radical must be what? Right? So I'm going to write it this way. Must be greater than or equal to 0. That's how we would set it up. We'll do one of those in a minute. If the function is a trig function, like y equals sine x, y equals tangent x, we have to think about whether there are vertical asymptotes. So we want to say then check for vertical asymptotes. Which are the ones that have vertical asymptotes? Do the sine and cosine curves have vertical asymptotes? Some people aren't showing me that. Well, here's what I can do. I'm just going to graph the sine curve. Zoom 6. Here's the way the sine curve looks. Remember that from pre-calc? Does it have vertical asymptotes? No, so we're fine. Cosine is going to be the same way, no vertical asymptotes. But look if I put tangent. If I graph tangent, it has all of these discontinuities. So I would have to check for those and have to state that x cannot be equal to those. For tangent, it's going to end up being pi over 2, negative pi over 2, negative 3 pi over 2. And I'll show you how to write that in just a minute. Find the domain for these. So I look and I see what kind of function I have. It's radical. So I have to check. It's a radical. Is it an even radical? Is it? Yeah. So therefore, if it's an even radical, whatever's under the radical must be greater than or equal to 0. So therefore, x must be greater than or equal to 2. So in interval notation then, 2 to infinity with a bracket around the 2 is going to be our domain. For letter B, this is a cubic function. Cubic functions, we check, do we have any restrictions? It's not rational, it's not an even radical, it's not a trig function. So therefore I know the domain should be anything, all real numbers. Hopefully you know what this looks like. Cubic functions are like this. If it has a plus 2, it's going to be shifted up 2. It's going to look like that. The next one, this is a rational function. Rational, fractional. The denominator cannot be 0. So I would say x plus 3 cannot be 0. x cannot be negative 3. How do I write that in interval notation? Well, here's what we have to do. Negative infinity to negative 3 union negative 3 to infinity. The union means or. So it's saying that the number that we choose has to lie in this region or it has to lie in this region. Those are the only x values we can use. Let me show you what that looks like on the graph. If I go to y equals, I can look at this and I can see that domain. I have to put in my function. I'm going to do a zoom 6 to get it on my standard screen. Here's the way it looks. If I look at my table of values, I can see that I have a value unless x is negative 3. If x is negative 3, I have an error. And so that's why negative 3 is not in my domain. For number 4, for tangent. Tangent is a trig function. I have to check for vertical asymptotes. I could look on the graphing calculator like I did a minute ago, but I can also think that tangent is y over x. So if I think of my unit circle, this point here is 1, 0, this point's 0, 1, this point's negative 1, 0, this point's 0, negative 1. If tangent is y over x, then I'm looking for where is it that x is 0. Anywhere x is 0, it's going to be undefined. So what is this right here? How many radians? Pi over 2. What about this? Okay, what if I went in this direction? What would I call it? Okay, so my domain then is actually going to be kind of weird on this. It's going to be dot, 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 negative pi over 2, comma, pi over 2, union, pi over 2, comma, 3 pi over 2, dot, dot, dot. So what I'm showing here is that there's a pattern. At every multiple of pi over 2, and I should say odd multiple of pi over 2, then there is going to be a vertical asymptote. So this would be saying, don't use pi over 2, don't use 3 pi over 2, don't use 5 pi over 2. Okay, that would be our domain. Another way I could put it, well, let's just stick with that. I could also state it like, I could say x cannot equal pi over 2k, where k is an odd integer. Why do I have to specify an odd integer? Go ahead. Yeah, if I had 2 as my number, what's 2 times pi over 2? Pi. Pi works, doesn't it? Pi is in our domain. That's why I would have to specify that k is an odd integer to make this work. Integers are any numbers, positive or negative, whole numbers. So like negative 2, negative 1, 0, 1, 2, 3, etc., etc. All right, a piecewise function now. Sometimes people get confused on this. Functions have only one output for any given input. And I see so many people who give me 2 answers for this. If I'm doing f of negative 3, that means to figure out, am I going to plug into the first function or the second? Well, I check my x value, and it's less than 1, so it's going to get plugged into the top function. So it's going to be negative 2 times negative 3 plus 3. And that's going to give me 6 plus 3 is 9. If I want to do f of 0, which one's it going to get plugged into, the top or the bottom? Top, because it's my x value is less than 1. What are we going to get? 3. If x is 1, where does it get plugged in? Bottom, so it's 5. Let me show you how we can put these on the calculator. I'm not so sure that you guys learned how to put graph the piecewise functions. Did you guys learn how to graph them on the calculator last year? Piecewise functions?
I recognize that.
Okay, let me do it. Here's what I have to do. I have to say you're going to graph negative 2x plus 3. But then I have to say it's going to be divided up, so I'm going to do divided. And then I'm going to tell it only to graph this if x is less than 1. All right?
Where did you get the lessons?
It's under test. Second math is where the test is. So what I have to say is, calculator test it out. So this is under test. You're only going to graph this when x is less than 1. Then I go down to y2. I'm going to put in x plus 4. And then I have to say it's going to be divided. So I push that divided. I have to use parentheses. And I say x. I go to that test. They have to test it and only use this when x is greater than or equal to 1. And so now when I graph this, it should graph it only, so it's graphing the first one only when x is less than 1. It's graphing the second one only when x is greater than or equal to 1. Watch how helpful this is now. Go to your table. Second graph to go to your table. I can look at this and I can see when x is 3, the answer is 7. Let's check these other ones. When x is 1, the answer is 5. When x is 0, the answer is 3. And at negative 3, the answer is 9. So the calculator knows which one to plug it into because we gave it that stipulation of the less than and greater than. So f of 3 was 7. Later on, we're going to be graphing those piecewise functions, and you can use your calculator to check. All right, shifting now. Y equals f of x minus c. What kind of shift is that? Right? Yes. And guys, if you didn't know that, some people in first period are like, they didn't know for sure. So I said, well, just graph x squared, and then instead of using an x, use x minus 3, for example, squared. And look at the comparison. So here's x squared, and then here's x minus 3 quantity squared. Can you see how that shifted to the right when we did that? So this is going to go to the right c. This is going to go to the left c. What's this do? Up. And if you didn't know that, you should use your calculator. Down. What's this? A reflection over? No. It's a reflection over the x-axis, actually. This would be like comparing y equals x squared to y equals negative x squared. That means that our outputs are going to get multiplied by a negative. So if my y values get multiplied by a negative, my y's become negative, it's going to reflect over the x-axis. This is going to take my x's and change the sign. So look, guys, if I have this point, and say this point's 3, 1, and I make it negative 3, 1 to change the x but not the y, where's the reflection over which axis? Y-axis. And this would be over both axes. And reflecting over both axes is actually the same as reflecting about the origin. All right, let's go over here now. We're going to graph these. We would like to try not to use the graphing calculator unless it's absolutely necessary. First one, pretty straightforward. Y equals 2 minus x. Everybody should know that my y-intercept would be 2, and my slope is negative 1. Should really use a straight edge, but I'm just going to go like that. Okay, so stating our domain and range, my domain here is negative infinity to infinity, and the range negative infinity to infinity. Now, this is based off of the parent function. You should know what this parent function looks like, square root of x. You should know it looks like that. Okay, so what kind of a shift is that going to be? To the, which way, guys? Left 2. So now it's going to look like that. So the domain then is going to be from negative 2 to infinity. I can use negative 2. Anything higher than negative 2 can be used. What's the range going to be? Good, and I have to use a bracket around the 0. The next one is probably something that you wouldn't know what it looks like immediately. Does anybody know what it looks like? All right, so if we don't know, we might want to just make some x, y points. I can check 0 in there. That'd be square root of 16 is 4. I could check 4 in there pretty easily. 16 minus 16 is 0. That's square root 0. What about negative 4? Negative 4 squared is 16. What am I going to get there? Can I check 5? Am I allowed to check 5? What's going to happen if I check 5? I'm going to get what under there? Negative. I can't do that, so I can't check 5. So I know that my x's, I'm only allowed to go from there to there. So I'm going to plot those points. You may have an idea now of what it might look like. What if I did this? And now I square both sides. And I take this over. Would you know what this shape is? That's a whole circle there. But, so what is this going to be? It's not going to be a whole circle, it's just going to be semicircle, yeah. So it's going to look like this. So our domain then is going to be from, oops, bracket, negative 4 to 4. Those are the only x's I can use. And then the y's, what are they going to be? From 0 to 4. Okay. The next thing is something you've learned about several times, the vertical line test. If any vertical line touches a graph at more than one point on the graph, then y is not a function of x. Determine whether y is a function of x. All right, so I want to solve this for y first of all. So I'm going to take the y over here, and I'm going to take the 15 over here, just rewriting it. Like I said, we want to use the calculator only if necessary. We shouldn't be necessary here. You should know what y equals x squared is. What kind of shape is that? Opens where? Up. And then what's this going to do to it? Shift it down 15. So I know this function is going to look something like that. That's down 15. So does it pass the vertical line test? Yeah. So yes, it's a function. As long as it doesn't hit it twice, it is a function. What kind of shape is this? Circle. Is a circle a function? No. It does not pass the vertical line test. This one is a little tricky. I have no idea what this looks like. I'm going to have to use the calculator. So I'm going to do x squared y plus 6y equals x squared. I'm getting the y terms by themselves. So this term stays, that term went over. I want to get just one y instead of two y's. So how can I get a single y instead of having two y's? Factor it out, good. So I'm going to factor out a y. And now I want to get y all by itself, so what should I do? Get rid of y times this, I should just divide. So I'm going to divide both sides by x squared plus 6. Okay, so now I don't know what that looks like even. So I'm going to go ahead and go to y equals. And it's x squared divided by x squared plus 6. And do a zoom 6. I'm going to look at it. Is it a function? Does it pass the vertical line test? Yep. So it's good. Yes, it's a function. All right? So pretty easy stuff. So your assignment is up there on the board.